Thank you very much, and thank you all for being here. I feel very passionately about this cause that we're all supporting. Some of you know I lost my own wife to glioblastoma about 5 years ago, and so I'm determined that with my last dying breath, I will be fighting this disease. And so I thank you for your support of this wonderful organization. So I've actually been looking forward to this evening for many months because I now get to introduce to you one of my favorite scientists in the whole world, Kevan Shokat. Kevan got his undergraduate degree from Reed College. Do we have any Reed College alums here? So I guess that's you. He then obtained his Ph.D. with the famous Peter Schultz at UC Berkeley before doing a postdoc with Christopher Goodnow in immunology at Stanford. He started his own laboratory in 1994 in the Department of Chemistry at Princeton before moving to UCSF in 1999. He's currently a Howard Hughes Medical Institute investigator. He's also a professor of cellular and molecular pharmacology at UCSF, and for good measure, he's also professor of chemistry at UC Berkeley, if I'm not mistaken. Kevan has consistently, in my opinion, been one of the most brilliant and creative scientists working at the interface of chemistry and biology. Early on in his career, he developed extremely powerful and very clever tools for studying a very important class of enzymes referred to as kinases that play critical roles both in normal physiology, but importantly in many diseases, including cancer. And you may know that many of the new precision cancer medicines actually target these so-called kinases. As if that wasn't enough, however, he then proceeded to do groundbreaking work on a protein that for decades was considered undruggable, referred to simply as RAS. This, if you will, has been one of the 800-pound gorillas in cancer medicine and cancer biology because we know it's a bad protein, we know we need to turn it off, but for decades no one saw a path to turning this molecule off with a small molecule. And then Kevan Shokat came along and again did some of the groundbreaking work which laid the foundation for developing the first class of truly specific inhibitors against this RAS protein, the first of which, sotorasib, was approved in 2021 and is already helping patients around the world. So for his many, many contributions to science, I won't list all of his prior honors. Suffice it to say, he was elected to the National Academy of Sciences and the Institute of Medicine in 2010, and the next year he was elected to the American Academy of Arts and Sciences. So Kevan, it's really a true pleasure to tell you how thrilled we are that you're receiving this award, and it is truly so deserved that you received this Hope Funds Award. Thank you.
Wow, thank you, Bill. That's it's a real special honor. The award is one thing, but to be introduced by Bill, that's exceptional. Really, really appreciate that. I'd like to thank the Hope Funds for this recognition, and Leah for all the organization, and Charles and the Board of Trustees and the scientific advisors. It's a real honor. I know the work that this award recognizes from my lab really had its foundation in several other Hope Fund awardees' work. We heard at lunch about Janet Rowley, who identified the Philadelphia chromosome, and then another awardee, Brian Drucker, and a current tonight awardee, Nick Lydon, who you'll hear from, really set the stage for the idea that if we could identify the genetic driver, we could identify a drug that would have a major impact in cancer. Now, back in 1983, another awardee, Bob Weinberg, among others, discovered that the gene that Bill just mentioned, RAS, as the first human oncogene. So this is the first time we identified a point mutation that drives a cancer. And since then, we now understand that 20% of cancer is caused by the disruption of this 800-pound gorilla. And so from 1983, there had been a huge race to identify a drug that would bind to this protein. But this protein was very recalcitrant or undruggable. You can think of it like a bowling ball. And there was really no place to put a drug that would fit into a cavern on the protein and block its function. And so when I arrived at UCSF in about 1999, my good friend and colleague Frank McCormick, who had been studying RAS for the previous 20 years, really started telling me how important this protein was, how there's no other way to treat these patients unless we came up with a drug. And then in about 2008, I had two people join my lab, and this is sort of, the stage that Frank mentioned. Students come to your lab, they're very eager, they have a lot of intuition, and they really have a lot of drive. And I told them about this project, and they both eagerly jumped into it, even though we had no idea how to do it. So with two people in the lab, I began to think very hard and noticed that there was one opportunity maybe in the lung cancer version. So I should say this is predominantly found in three cancers: pancreatic cancer, where almost all of the pancreatic cancer is driven by this gene, lung cancer, colon cancer. And so we found one variant in lung cancer that had a specific mutation with a residue called a cysteine. And you can think of this chemically as a little piece of superglue. And so we decided to go after that one residue. It wasn't the most common, but we figured if we could learn something. And as we applied some technology from another colleague of mine, Jim Wells, collaborations, as you know, you'll hear, are very, very important. We identified a starting point, and when we solved the structure, we realized it wasn't really a bowling ball, it was a piece of silly putty. And if we had the right drug, the silly putty could fold around the drug. And that was the pocket that led us to the first strategy, and that led companies to pursue them, and that's the sotorasib drug from Amgen that was approved in 2021. And what's really exciting is now we see pancreatic cancer drugs entering the clinic last year for different mutants. And so now we have a pocket to go after, and now there's a strategy. So, all of us in the room that do science know how hard it is, how much failure there is. And what I think is really, really important is foundations like the Hope Funds really provide scientists at that critical point when they have that drive and that curiosity to go after a problem, and funding them at that critical point. And so I thank you for that. You'll hear it, but I think other kinds of funding do not support the kinds of groundbreaking work that can lead to major discoveries. So thank you for that, and thank you all this evening, and thank you for the award.